All right, good afternoon, everyone. How's everyone doing? Welcome and thank you for joining us. We would like to go ahead and get started. I would like to extend a warm welcome to all of you joining us today for our Medical Engineering Graduate Recruiting Info Session. It's a pleasure to have you here, and we're excited to share more about the opportunities in our program. Before we begin, a quick housekeeping notes. Please keep your microphones on mute during the presentation to minimize any background noise. We'll have plenty of time to go over questions at the end, so please feel free to jot them down in the Q&A section, and we will address them during that time. Here's a brief overview of our agenda. We will start with a welcome note, then talk about events in the Tampa Bay. We will highlight our USF campus and then give you the opportunity to meet our team and then go over research areas, some faculty vibes, and then the program requirements. Without further ado, now to kick off our event, I'm honored to introduce our first speaker, Dr. Robert Frazina, the chair of the Medical Engineering Department and a distinguished professor. Dr. Frazina has been a leading figure in the field, and we're fortunate to have him here with us today to provide a welcome to you all. Dr. Frazina, the floor is yours.
Thank you, Shireen. And Shireen is our great department administrator, if you didn't know, and she's put a lot of work into putting this event together today. So we thank her for that. And thank you all for joining us. We've had a great registration for this event. We have interested students from over 120 or from over 20 countries. And consistent with this high diversity, we have a very diverse faculty, staff, and student body. In fact, right now, University of South Florida is one of the top 20 largest universities in the United States. And according to US News and World Reports, which is one of the main rankings, as most of you know, we are the university with the fastest rise in university rankings in recent past. And lately, we've been consistently in the top 25 or top 45 public universities in the United States. And our Department of Medical Engineering, which runs all of our biomedical engineering BME grad programs, we're a true joint department with our medical school, which provides our graduate students with unique opportunities to work on translational medicine projects, as well as basic science projects and engineering graduate projects for your master's or PhD. We also have close interactions with Moffitt Cancer Center, if you're interested in cancer research. And Moffitt is actually located right in the middle and around our spacious and beautiful campus here in Tampa. And Moffitt is the only NIH designated comprehensive cancer center in this region. Our own Department of Medical Engineering carries out all the grad programs, the BME grad programs, as I mentioned. We're a unique, dynamic department with tremendous new or newly renovated multidisciplinary lab facilities for both student labs and research labs. And our faculty have consistently been at the $20 to $30 million federal grant support level at a given point in time. And most of these come from NIH and NSF. Also, we have our faculty and students now have many patents, many dozens, and some successful startup companies. So if you are interested in innovation and commercialization, our BME grad program is a great place to be. And these levels of research, commercialization, startups, they're on a per faculty member basis, they're competitive with most of the top BME departments in the United States. And our graduates get great jobs in industry, or a few also go on to jobs or PhDs in academia at top universities. So I hope partly through today's event, you will find a member of our BME faculty who you would like to work with at the graduate level. So I hope you can come join us at our sprawling modern campus in the beautiful growing city of Tampa, Florida. Now, to follow up today, the way it's going to work is if you have a particular interest in working with a member of our BME faculty, which could involve visiting Tampa if things proceed well in terms of contacting the faculty member and speaking with them on Teams, then we can engage you further on an individual basis after today's event. Okay. So these just feature some of the many fun things to do in the Tampa Bay region. We have top amusement parks like Busch Gardens, which actually is just down the street from our main campus. St. Petersburg and Clearwater have been voted #1 beaches in the US on and off in recent years. We have top sports teams, sometimes called Champa Bay, although that's quite not happening this year. But we have major sports teams in the highest leagues in the US. And there's really a neat area downtown that's just being developed as all the time. It's expanding. It's along the Hillsborough River, which empties into Tampa Bay. All kinds of things to do down there. Great restaurants, clubs. We have Ybor City, which is a nationally designated historical area. Lots of beverage places and great places to eat there. And we have some national events like Gasparilla. So a lot to do, and we have a Q&A part at the end. You can ask more questions about this. Next slide. And Tampa and Florida are sort of recreation, exercise type areas, lots of facilities on campus, near campus, which you can get involved with. We have 2 BME related student societies, as well as others that are also related that you can get involved with. Of course, lots of water with a great river system and Tampa Bay, a lot of water sports. Our campus has a lot of modern buildings, and we have plenty of space for expanding new buildings, which could occur while you're here. It is a Research One university that does emphasize Division I athletics, and there's many areas that are beautiful, have beautiful southern landscapes and gardening and things like that. Next slide. Okay, we got a video.
No audio.
We did have audio on this. Let's see if we can get that corrected. There we go. Okay, so you can see a little bit of everything in that video, which reinforces the diversity of our large campus and the opportunities that grad students have. Now, in terms of affiliate institutions, Tampa General Hospital is the major tertiary hospital, very research oriented, and that is the hospital that's aligned with our medical school. So we have opportunities to go down there to work on translational projects. We even have some of our engineering grad students going into operating rooms if that's part of their project. I already described Moffitt Cancer Center. That's one view of one of the main buildings on our campus. We actually have one of the two largest VA hospitals right across the street called James Haley Veterans Hospital. And in terms of biomedical engineering, we have one of our top research centers on campus develops prosthetics with actually working with doctors and patients from the VA hospital, missing limbs, arms, legs, and things like that. USF Health is the name of our overall medical school organization, which also includes pharmacy schools, nursing school, and other things like that. And it has a major new, wonderful new building in the downtown area of Tampa. USF Connect is an area where we have more modern research lab buildings. My research center is in that cluster of new research buildings. And then we have one of the top orthopedic institutes called Florida Orthopedic, which is highly affiliated with our orthopedics department at our medical school. And we have pretty good ties and relations with them if you want to get into biomaterials, orthopedic type projects. Next. Okay, housing. We do not have dorms for all 50,000 students on campus, but the good news is we have a lot of really nice, neat complexes, pools, beach volleyball around campus. And these complexes are specifically developed for our students, including our grad students. There is a grad student dorm complex, but I think we have, I don't know, total, not sure how many grad students we have total in the university, but there, so there is a possibility of getting into the lab or the dorms for grad students, as well as these adjacent apartment areas designed for students. Next. This is a little map of our area. So let's see, okay, this is more downtown in the middle, and then you can see the large logo for University of South Florida, the green bull logo. That's up in the upper right, but you can see that's designated here. Busch Gardens is nearby, and then you can drive east for about an hour and a half, and you can go to Disney World, Universal Studios, all the Orlando things. Miami would be down at the southern corner of the state, which is drivable. And then I mentioned some of the top beaches in the US, which would be 30, 40-minute drive from our main campus. So a lot going on. And we have an award-winning biomedical engineering student society who have received honors from the National Society almost every year since it was formed. And then we have some other related women in engineering and biomedical engineering student societies. Here are some of those listed here. Okay, next. Okay, so what we're going to do is we're going to briefly say hello from faculty and staff that are here. Some are not here because they are at national meetings or NIH study sections or other important meetings, but many of us are here. So the ones that are here will introduce themselves, and I'll just introduce the others to you. And then later on, we're going to feature our faculty that are particularly looking for new BME PhD students because they have full funding at this point in time. Okay, so you met Miss Shireen, you have met me. Terry Fox is a great resource for our department, which you will not find in most BME departments. She is dedicated to helping students get jobs, basically. She does a lot of our industry relations. She works with each of our students individually on resumes, interviewing skills, finding industry to companies to apply to in the Tampa Bay region and nationally. So this is a great person that most departments do not have. Next. Mary Nicholas is our undergrad advisor. She is not here today. And then we do have a graduate academic program specialist that would work with you and me on your graduate program. And we're filling that position right now. Okay, and now we'll go through just the slide on each faculty member. We've each put down some words of wisdom and our research interests. So for me, persistence is big in life. Next slide. And I think Dr. Akintui is here. Do you want to say hi?
Hello, everyone. I'm Kemi Akintewe, and I primarily teach undergraduate students.
Okay. And next is Dr. Iskari. Just a quick hello at this point.
Hello. Nice to be with you guys.
Very good. Dr. Bulasheva.
Hello, my name is Anna Bulasheva, and I'm an assistant professor here at USF, and I am recruiting 2 PhD students at this recruiting event. Thank you.
Very good. Dr. Heller, I think, is in Europe teaching about gene and drug delivery. So he's not available at the moment. Next. And Dr. Jaruzelski is on an NIH study section. So he's not here with us. Dr. Zhang is on a semi-sabbatical. So he's not here with us today. Dr. Kim is with us.
Hello, everybody. Name is Albert. I'm associate and professor of medical engineering. Like any others, looking for one graduate student. Thank you.
Okay, we'll hear more from Dr. Kim later. Next. Dr. Latifi is I think she is here.
I'm here. Hello,
Yes.
everyone. This is Neda Latifi. I'm also an assistant professor in the department working on tissue engineering stuff.
Very good. And Dr. Otten, is he here? No. Okay. He's one of our professors of instruction, but he does do research on gene and drug delivery, especially the electronics side of it. Next. Dr. Pasaglia.
Hello, everyone. Chris Pasaglia here. I'm a professor and associate chair in medical engineering, and I'm interested in all things related to eye and vision research and am looking for students as well.
Great. Dr. Safa's here.
Hey, Babak Safa here. I'm an assistant professor of medical engineering, and I'm looking for students to study glaucoma and biomechanics.
Excellent. Dr. Spiru is here.
Okay. Hi, everyone. George Spiru. I'm a professor in the department, neuroscience all the way. And we have an opening for one graduate student coming up for next year. So, and you'll hear more about our research in the next segment.
Great. Last but not least, is Suhail here? No. Okay.
Yes,
He's
sir.
another.
I'm here.
Oh, okay.
I'm here. Sorry,
Just-
I was talking without microphone.
Yep.
So, Suhail Zekri, Associate Professor of Instruction. I work on design of devices. So we have predominantly undergraduate capstone experience, although we are developing a graduate one, but it's at the pilot step right now. Looking forward to more graduate students coming and being very excited about BME work here.
Great. Okay, is this Dr. Pasaglia take over?
Yep, I'll take over for here for a little bit.
Great.
So the research that you saw amongst the faculty that have just introduced themselves have been divided, as well as other research going on at University of South Florida. We've divided them into 4 research areas in our department. One is biomedical imaging and bioelectronics, and there are core faculty members of our department listed above, from Latifi to Ascari. But then in addition, there are faculty across the campus who do research in these various areas. So in this particular area, the names below do research on either imaging or bioelectronics, and students can work in a core faculty member's lab, as well as any of the affiliated BME faculty researchers listed at the bottom. So that's one area. Second area is cell and tissue engineering. Again, the top lists the core faculty who do research in this area, and the bottom are affiliated faculty across the campus and affiliate university institutes. Third area is molecular medicine and drug delivery. And our fourth area is neuroengineering and rehabilitation engineering. So I guess let me just introduce this. In this point now, we're going to give you a series of just sort of quick snapshots of what various researchers who are looking for faculty, snapshots of their research lab, so you can kind of get a feel of the specific projects that they're working on. Starting off will be Mason.
Yes. Hello, everyone. Nice to be with you guys today. My name is Maysam Asghari. I'm an assistant professor in this department. I'm fortunate to be here with you guys. I'm looking for one PhD student. My research is mostly on structure function mechanics relationship in human tissues, and my focus in human aorta. And I look at it specifically, I look at the abdominal aortic aneurysm, which is the mortality cause across the world and in the US. And the final aim is to come up with with ideas to design, grafts for abdominal aortic aneurysm substitution, and these design these design principles come from learning from the tissue mechanics at different scales, looking at the very smallest scale with advanced technologies like atomic force microscopy, electron microscopy, up to higher scales to tensile testing, and learning about the mechanics of the tissue and coming up with ideas to replace these tissues. For example, in latest study, we used porcine aorta. We decellularize it and recellularize it with human stem cells, and we are hoping to do this in next steps. The next line of research that I have in slide 2 is looking at the mineralized tissue, and mineralization could be helpful, could be harmful. In helpful case, you can look at your teeth, and in harmful, you can look at the mineralization of aorta, which is called a stenosis. So we look at the nucleation of these hydroxyapatite particles inside the tissue, and how this nucleation and development of mineralization occurs at different levels, at the interfaces and different levels. And at the end, we use whatever we learn from tissue structure and mechanics at different scales to design materials for real life applications. You can look at the bottom right. We made a shell that is inspired by the structure of a beetle exoskeleton, and this is just, this is based on the natural design principles that are hidden in crustacean or natural materials structure. We look at these with advanced technologies. We extract these design principles and we use them to design advanced materials in this case. So I'm looking for one PhD student full-time, and my work is mostly experimental. I expect someone that is dedicated to learn new skills, advanced nanotechnological skills, and I'm passionate to work with you guys. I hope that you are interested in my research.
Greetings, my name is Anna Bulshova. I'm an assistant professor of biomedical engineering here at USF. I joined USF 2 years ago, establishing a gene therapy and regenerative medicine research laboratory. Currently, I have 2 open PhD student positions. Research directions include developing non-viral gene delivery protocols and biomaterial manufacturing techniques for regenerative applications. Major project directions include the following. The first direction focuses on developing gene transfer protocols for skeletal muscle delivery for protein replacement therapies, such as type 1 diabetes, GLP-1, or other metabolic disorders. The second focuses on developing gene transfer protocols and biomaterials for heart regeneration post-myocardial infarction. The third focuses on developing biomanufacturing techniques such as electrospinning, microfluidic extrusion, and bioprinting for volumetric muscle loss and tendon and ligament engineering. If you have any questions or would like to join the lab, please reach out to me. My email is abulasheva@usf.edu. Thank you for your attention.
Hello, everyone. This is Albert Kim, Associate Professor of this department. My research is across many different disciplines. I do work on the different area, but mostly are about the device. I make the device for heart disease. I make the device for wound healing, dental, brain, cancer, and across the different areas. So as an example of it, I just going to play the video that introduces one of my examples. My name is Albert Kim. I'm Assistant Professor of Medical Engineering. Medical engineering is quite an interdisciplinary field that requires different skills and different knowledges. A student who is interested in medical engineering should come in ready with open mind for dynamic and rapid learning. Our recent work has been featured in the IEEE Transaction Biomedical Engineering as a cover page. We developed totally implantable oxygen generator, or called TIO, which can deliver oxygen to address hypoxia. Using pulse electrolysis, our device can deliver a high amount of oxygen without the chlorine generation over long term. TIO is implantable, biocompatible, lightweight, and wireless controllable, which making attractive candidate for clinical application. One application we're thinking is reversing hypoxic cancer tumor, such that it can pair with the mainstream therapies, such as radiation therapy. It is expected to increase efficacy of radiation therapy and reduce the side effect and other treatment times. This interdisciplinary project was done by biomedical engineer, electrical engineer, and radiologist. Researchers with a different background could learn other disciplines outside their domain. For example, Dr. Simon Islam, who is a leading author of this project, is an electrical engineer who now understands the biological side of cancer, hypoxia, and oxygen in the human body. Propose.
Hello, Chris Pasaglia here, and I am the director of the Ocular Neuroscience and Neuroengineering Lab here at the University of South Florida. The research interests in my lab are to understand how visual information is represented in the eye's input to the brain, and to elucidate how this representation changes as ocular diseases inflict damage to the retina. We then use these experimental insights to engineer diagnostic and therapeutic devices for the treatment of eye diseases. My lab employs a variety of methodologies to achieve these research goals. We develop and use our own bioinstrumentation. We perform acute and chronic electrophysiological recording of neural activity. This includes surface recordings, single electrode, microelectrode recordings, and patch clamp recordings. And we perform computational analyses of the data to form models of how we and other animals see. These are the bread and butter techniques of the lab, but we've also been known to dabble in optical imaging of cell and tissue morphology, performing histologic and pharmacologic assays of cells to understand how they communicate with one another, and to perform behavioral assessments of the visual abilities of animals to understand their limits of seeing. My lab is funded by grants from the National Institutes of Health, which have several focus areas currently. One is to identify and model cellular processes and network computations that formulate the retinal output. Second is to quantify intraocular and intracranial pressure variability around the clock in conscious animals. We do this using the device shown in the left bottommost panel. It is a wireless intraocular pressure sensor that records eye pressure via a tube that's implanted in the eye. And it sends that data to a laptop next to the animal to monitor eye pressure. We can also put that tube into the cerebral ventricle to monitor intracranial pressure. In addition, a third research aim of ours is to investigate circadian and other autonomic mechanisms that regulate intraocular pressure. We also measure and manipulate intraocular pressure dynamics in conscious animals using the device shown in the middle in white, which draws fluid from a reservoir and infuses it into the eye through the pump to allow us to hold eye pressure at any level we want and induce glaucoma in the animal under study. And a fifth focus area of the lab currently is to characterize retinal neuron morphology and physiology in normal and hypertensive eyes. For further information, I refer you to the lab website, and if you're interested in working in the lab, contact me at pasaglia@usf.edu. We are looking for 1 to 2 students this year. Thank you.
Hi, my name is Dr. Babak Safa. I'm the director of Ocular and Soft Tissue Biomechanics Lab here at USF BME. So we work on glaucoma and biomechanics. So the main areas that we focus on are biomechanical testing of soft tissue, computational biomechanics, clinical research, biology of ocular tissue, and animal studies. So currently I have 2 lines of research open for graduate student recruitment. The first one involves investigation of glaucoma pathophysiology using finite element modeling and OCT imaging, which is more of a clinical research-oriented project. And you can see the diagram in the below, which highlights the areas of interest needed for this project. And the other line of research is examination of inelastic biomechanics and tissue remodeling in glaucoma, using mechanical testing of soft tissue and bioengineered material, as well as cell culture and finite element modeling. So by the end of the time that you would graduate from my lab, whether you're doing a master's degree or PhD, you would have an expectation to have at least professional understanding of these 5 areas of interest in my lab. But of course, with various degrees of expertise, depending on your immediate area of studies in that project that you were involved with. So if you have any questions, feel free to send me an email and go visit our website at safailab.com.
Good afternoon, everyone. I'm George Spiro, and I'm the PI of the Auditory Development and Connectomics Laboratory. And as the name implies, we have 2 main research areas in the lab, one auditory development. And there we're looking at formation of neural circuits. We use mice as our experimental animals, so we're looking at their late embryonic ages in the first week or so after they're born, which is the equivalent of the 3rd to 5th months of human gestation when the brain is putting itself together very, very rapidly. We use a range of technologies, structural technologies, imaging over large volumes using light microscopy, fluorescence, and electron microscopy. And we're looking not only at neurons, but also the glial, the non-neuronal cells. Here's an image of an astrocyte, but also at the blood vessels. We're looking at the functional maturation also using electrophysiological techniques, patch clamp, current and voltage clamp, using brain slices, ex vivo brain slices. We're looking at gene expression. And so we want a multifaceted view of this whole process. And then we're going in to manipulate the system, and one strategy is to use viral vectors. And for example, now we're exploring the roles of spontaneous activity, that is activity in the absence of, in this case, an auditory stimulus, and what role does that electrical activity play in generating all the gene expression mechanisms that drive all of these changes. Now, our other project is very focused on brain wiring and what we call connectomics, and we do it at nanoscale. That means we're looking at large volume electron microscopy image sets, and there we can extract the neurons and we can map the synapses. And from that then, there's a lot of image processing and applications of machine learning to auto-segment the tissue, extract the objects, which are the neurons, and then convert them into a format where we can put them in silico and connect them up and see if our circuit in silico is matching the behavior that we know the cells exhibit when we record in vivo in response to sound. So this is a way of testing our understanding of the circuit, and then also a way to investigate biologically inspired AI that may improve its computing capabilities when based upon the kind of neural architectures and circuit architectures that we discover. We also use virtual reality software that was developed out of our laboratory, and you heard a couple of pictures of the lab. And so if you're interested in any of these topics, please contact me and we can continue discussing as the session goes on.
So we just gave you a little vignettes of the various faculty in our department who are currently and actively looking for student researchers, and hopefully one or more of those labs interested you. I would also point out that between now and next fall, new funds can come in. So there are additional faculty researchers who may not have presented that might end up looking for students. In addition, there are those research areas that were covered at the very beginning of not just faculty in the core department, but outside the department as well, who might be interested in students. So if one of those research areas or one of these specific research labs interested you, I would encourage you to apply to our program. Next slide, please. So if you do apply, the admission requirements for the master's program are highlighted here. They're also available to you on the department website. And I'll just summarize it here. Undergrad GPA is typically going to be 3.0 or higher. The GRE is required, but it's not. If you're an engineering student who's graduated from an ABET accredited engineering program, then it would be waived. And TOEFL scores are in requirements are provided there, and 2 letters and so forth. The BME curriculum has laid out similar to what I'll lay out later for the PhD curriculum, and that is that there are 2 required courses, specifically Research Innovation Principles and Practice and Biomedical Data Analysis, which is a statistical course that's required. There's 30 credits in total that one would need to complete the degree, and those 2 courses consume 6 of those 30 credits. Then an additional 9 credit hours must be taken to fulfill a life science and an analytics requirement. 1 course is needed for fulfilling the life science requirement amongst those 4 that are listed there. And then 2 courses from the list below are needed to fulfill the analytics requirement. So that makes up a total of 15 courses that are sort of set, 15 credits that are set, and then the other 15 credits that make up the BME master's degree are elective courses for across a whole list of courses available to you in the department as well as across the college. In taking those elective courses, you can choose to pick them in specific areas that we've outlined that would provide for a concentration that would be listed on the master's degree. And these concentrations are in the same research areas that we showed earlier. Those are neuroengineering and rehabilitation engineering, molecular medicine and drug delivery, biomedical imaging and bioelectronics, and cell and tissue engineering. In addition, we have a fifth concentration through the USF pharmacy collaboration in pharmacy. As a master's student, we offer two options for completing your degree. You could do it just through coursework, what we call a non-thesis degree option, in which case those 15 credits would all go towards elective coursework. Alternatively, you can apply 6 of those 15 credits towards a master's thesis and do a thesis tract where you would complete research in a faculty's lab as part of that. And students should consider the additional time that might take to complete that thesis research, which wouldn't be the case if you're just taking coursework. And I think I'll summarize that in the next, oh, no, I guess we don't. So you can, if you go back a slide there for a second. So based on the 30 credits of research, you can figure it's going to be about a year to a year and a half to complete those credits. Hours, if you do thesis research, then figure another 6 months to a year for that thesis component. All right, next slide, please. And then on the PhD front, again, these requirements for admission are available on the website. They're listed here. The GR requirement is again waived for students who are from an ABET accredited engineering program. The GPA is slightly higher at 3.5 and above, or you could have completed a master's degree in BME. And that's everything here. Next slide. So in the case of the PhD curriculum, there's should be 90 credits there, not 60. There's a typo at the top. So there's 6 core requirements that are required. In addition, there's those 9 credit hours where 3 are life science and 6 are analytics. So the same as the master's requirement. And then you have the 15 elective course requirements, which make up the 30 that would be fulfilling a master's component. At that point, you would then have an additional 30 credit hours of coursework and directed research, at which point you would then also be doing, or at the conclusion of that, be doing a prospectus exam, which is an admission exam into candidacy. To complete the required coursework and directed research that consume those 60 credit hours, it's going to take rough and write up your prospectus. You can figure 2 to 2.5 years time frame. At that prospectus exam time point, if you pass that exam, then you will enter into candidacy and take additional 30 credit hours of dissertation research as you're doing your dissertation, and ultimately defend at for somewhere in your 4th year. Next slide, please. Oh. Am I frozen here? Are you able to hear me?
We can hear you. Your camera's frozen. It is on the next slide. I'm not sure if you don't see it. It's notable
I'm
highlights.
not seeing. I'm still seeing the PhD BME curriculum slide here.
Dr. Frazino?
Yeah, I'll pick it up since Dr. Pasaglia is having a little technical hiccup.
Thank you.
So one of the advantages of our PhD program, besides the flexible and sort of minimal required coursework, only really 5 required courses, which also applies to the master's. For the PhD, there's no separate qualifying exam. You give your proposal for your PhD research, and that counts as a qualifying exam. So there's no separate test. And even within the 5 required courses, there's some flexibility, as you saw. And you come right into the program, choosing your PhD major professor. So there's no mandatory year of having to go to different labs and taking different courses. And it's been shown that under this type of system, you can complete your PhD program quicker than if you spend the first year doing sort of general things. And other good news is we have full tuition, stipend, health insurance. So once you're admitted to the PhD program here at University of South Florida, everything is covered as far as expenses go. Next slide. So this is one way to get to the admissions website if you're US domestic. And then the next one is for international students. And we value both very much. Next slide. All right. So this comes to the end of our formal presentation. And now you can raise your hand and ask questions. All the faculty that were here at the beginning, I think, are still here. Okay, so Parsa Mackey, go ahead, unmute.
Hi, hello. Thanks so much for the great presentation. I'm Parsa Mackey from Iran, and it would be my honor if I could present myself. I have a bachelor's degree in electrical engineering, and I have great interest in bioengineering. I have done several projects related to bioengineering. To briefly mention a few, they're mostly related to the use of AI and bioengineering. Like I've done one to detect and remove artifacts from MRI scans, which allowed me to study the brain. I have done one for movement detection using received signals to detect any sort of problems that patients might face in hospitals, and one to detect poison, the type of poisoning based on the symptoms of the patient. So anyway, I'm looking for any sorts of any of you great faculty professors for any positions if you might be interested. Thanks so much.
Okay, thanks, Parsa. So the general procedure here is you, the students, have to sort of reach out to a potential primary advisor from either our primary faculty who you've heard from today, or you can reach out to affiliate faculty, which are featured on our different websites here at University of South Florida. So the next move is sort of yours, and we have 2 general conditions for acceptance into the PhD program where all your expenses are covered. First of all, you need to meet the academic requirements that Dr. Pasaglia went over. And second, you need to identify a major professor by contacting them, speaking to them on Teams, and if it proceeds well on both sides, we could even bring you to campus. And you would need to get approval from that advisor that they want you to join their lab. So those are sort of the 2 criteria. So after today's session, the ball's in your court to contact. Now, the other way to do it is apply online, and I will forward your application if you meet the academic requirements to our faculty that are looking And then that's a way for them to contact you. So you can either apply or you can contact our professors directly, or a combination. You can apply and contact the professors. And that's how you get the ball rolling on attending University of South Florida BME grad programs. Any other questions? Raise your hand.
I will help moderate the chat and Q&A. We do have a question from Fatima. She has a bachelor's degree and a master's in chemistry. She hasn't sat for her GRE yet, but she's wondering if she should apply now. She has a great interest in our program.
Well, like most, good news, bad news, like most United States engineering graduate programs, you generally have to have a bachelor or master's in engineering. Now, we have a special option for good science majors, including chemistry. We've had some come from chemistry, where if you're willing to spend a year or so taking prerequisite courses pretty much anywhere you want in engineering and math, then you can be admitted to our master's program. And once you get in the master's program and you get a semester under your belt where you do well, you can then apply to the PhD program. Otherwise, if you don't have a degree in engineering, then you would not be eligible for our BME grad programs, like almost every US university engineering grad program. Other questions from chat or live?
Yes, we have another one. It says, how can we use the application fee waiver code to apply to the program?
Okay, so the good news here is unlike most US universities, our application fee is only $30, not $100 or $150. And you can apply for a waiver when you apply. And if you apply and there's an issue about the $30, you can email me a copy of your application or a copy of your vita and transcripts, and we can discuss a fee waiver.
All right, I don't see any other questions, but I know we did receive a couple, Dr. Frazina, if you wanted to take a minute to go over those, please.
Can you read them to me?
Yes, 1 second, let me, sorry.
Okay, that's okay.
All right, the first question was, can I register for both the master's and the PhD program?
So the way we work it is you have to apply to one or the other. And one mechanism that has worked for people is they apply to the master's program, they come here, they get to know our university, our professors, our college, our research labs, and during their first or second semester in the master's program, then they apply to the PhD program. So that is one of the best ways, if you're not sure about master's or PhD, is get going in the master's program, and then you would have an advantage because you would get to know the professors, you could show them how great you are, and then apply to the PhD program, knowing a lot more than you did before entering the master's program.
All right, we have a question. I'm going to take a question from the chat. It says, does the fee waiver code only work for medical students? If you mean medical engineering, yes, other programs are not covered under this.
I can't speak. Go ahead. Go ahead.
Oh, no, please go.
No, I can't speak about the other programs, but I know that you can request an application fee waiver when you apply to the biomedical engineering master's or PhD programs. But like I said, and then that is processed by the grad school. If the grad school does not give you a fee waiver, then you can send me your Vita resume, your transcript. You can email those to me, and you could say, I really want to apply, but I can't afford the $30 fee, and then we can work together on that issue.
All right, next question. It says, I am currently in my final year in a bachelor's program in BME, and I am applying for the fall 2025 BME PhD entry. I'm wondering if you can go more into why there are not qualifying exams at USF. I am also interested in extreme physiology. Are there any specific professors that you all know that may do related biosensor research or medical research?
Sure. So the reason we don't have qualifying exams is, great graduate students in BME are, it's we have to competitively attract them since there are a number of BME, other top BME departments. So one of the attractions of our PhD program is you do not have to take a separate test in order to give your PhD proposal and graduate. Most programs have a separate test. So we do that to allow our students to work more on their research rather than studying for another test after they've completed all the coursework anyway.
Now, let me extend it even further.
Yeah, go ahead.
And so other reasons are that in some of us have been in programs either as students or as faculty members where there are PhD qualifying exams. And in those programs, ultimately what ends up happening is that students will lose a summer or semester studying and preparing for those qualifying exams. And that time is lost, and it's not time that they're able to spend on the research because they're very fixated and concerned about passing those qualifying exams, because if they do not, then they're eliminated from the program. And so by eliminating the qualifying exam, so additional time, as Bob has mentioned, gets focused on the research. Secondly, oftentimes those programs will, if the student does not pass their qualifying exam, they lack the desire to completely eliminate them. So they'll do some sort of remedial coursework to address that. So that's additional time that students are spending, doing other things besides focusing on their, thesis research and so forth. And it's for that reason that our students there's of course exceptions, but the majority of them finish in a 4-year time frame, whereas if you look at programs, if you're considering other programs that have qualifying exams and so forth, I encourage you to ask them what's the typical time to graduate. It's programs that have rotation systems and qualifying exams are going to have like 6 or 8-year times to defend your thesis, because these additional items end up taking time from students away from doing the thesis research, which at the end of the day is really what is required. And so we use our prospectus essentially to assess whether a student has the adequate biomedical and engineering skills to continue into the candidacy phase of the PhD.
All right. She had a second part to the question, which is her extreme interest in extreme physiology, and wanted to know if there are any specific professors that we know that may do related biosensor research or medical research in that area.
So in the vignettes you saw at least two that came to mind, Albert and myself. But there are others that on campus who do sensor-related research. And the student can kind of reach out to me and more directly, and we can get back to you with a list of faculty who are doing biosensor research. They'll reach out to them to find out if they're actually looking for students next year. Beyond, of course, Albert and myself.
Thank you. Another student is inquiring if we have any full funding for master's program.
So the convention in the United States is that good PhD programs like ours, we pay everything for the PhD students. The convention is that master's students pay their own way. And that's true of our BME master's program as well. However, there are some, not majority, but some cases where a master's student is doing really well. And in their final semester or two, they say, you know, could I be a TA, which will pay them a stipend and get them a tuition waiver. So we do that with some of our highly successful master's students, but you'd have to be here for at least a semester and, you know, do well academically.
All right, Marina has a follow-up question asking if there are any programs within the department that have any international collaborations with other universities or labs.
No, we don't have any set programs, but because we have about 80 grad students at any given point in time, we can work with you individually. So if you really want to go somewhere and internationally and have some sort of joint graduate degree, we can work with you on that, but we don't have anything cookie cutter set up for that right now.
All right, thank you. Going back to the questions we received earlier, there was one on how can I align my future career goals with the program?
Well, the first alignment would be choosing a major or a primary advisor. We call them major professors here at University of South Florida that is in your area of interest. But then once you're in the program, your advisor, you have a committee, whether if you're doing a PhD, you'll have a multi-faculty committee. If you're doing masters with thesis, you'll have a committee. You'll interact with the committee members. And then we have that professional industry liaison person that I mentioned earlier in the presentation. They can work with you. Most of our students go into industry and get really good high paying jobs. So we can work with you on that. We have a network of many, many dozens of BME related companies now in Florida and nationally. We have a department advisory board, which is mostly industry vice presidents and senior engineers and things. So we have a lot of mechanisms in our department. We don't rely on other mechanisms per se. We take the responsibility in our department to work with you until you get a great job or a postdoc if you're going to go into academia, or if you're a master's student. We've had some of our students get into some of the other top BME programs in the country for PhDs as well. And so we will work with you. So, and you know, most students change their mind a little bit when they come. So we'll work with you on what your professional goal is individually.
Thank you. I don't see any other questions that we did not cover earlier in the chat. And we did address the questions that we received before. Thank you. All right, if you have any further questions about the fee applications, please feel free to email me directly for direction. I'm putting my email in the chat box. We did receive one inquiry. I'm Austin from Nigeria. I am passionate about any research at the intersection of computer science and biomedical engineering, especially the use of AI and machine learning to build models that predict patient responses to various treatments based on genetic and clinical data, and any research system that use bioinformatics to design drug delivery mechanism tailored to individual patient profiles, especially unreached and undeserved communities. Also want to impact forgotten communities with education in this field. Any professors working in those fields?
Right. So the answer is yes. And in order to do that research in our BME PhD program, we would align you with one of our affiliate or related faculty who are in Moffitt Cancer Center, if you want to go into the cancer type area. And then we have researchers in the Department of Computer Engineering that also work in these areas. So we would set up, in that case, an interdepartmental committee. You would get your BME PhD, and we would get your primary advisor would be in one of those computer AI related programs. And that's definitely a hot area.
All right, we have a couple more questions. If undergraduate percentage is in the range of 50 and in master's having a 3.71 GPA out of 4, is that person able to get admission into the PhD program in physics?
Yeah, so this program today is for biomedical engineering. However, if you are a physics major, if that's what you're asking, physics majors take a lot of courses that are similar to engineering. So we have taken physics majors. It depends. I would have to look at the transcript.
All right, any other questions or inquiries for Dr. Frazina or any of the other faculty with us today?
Okay, Parsa's got his hand up again. What's up?
Hi, sorry, I have another question. If I do decide to just go ahead and apply for this for the field, would the committee decide where I would best fit and which position I would best fit, or should I choose the professor and where I think I would go better?
Yeah, that's a good question. You can do it either way. So if you decide that there's a faculty member that you really want to work with, you should definitely contact them, send them your vita, your transcript, and say, I would like, are you interested in further discussion, Teams meeting, Zoom meeting about me possibly joining your lab? So if you send your vita and transcript by email, they can look at it and decide if they want to have further conversations. The other way to do it is apply online to our BME PhD program. Then I will look at your application, and if you're academically qualified, I will give your application to our faculty who are looking for BME PhD students, and then they would contact you. So you can do it either way.
Thanks so much.
Mm-hmm.
All right, Grant has his hand up.
Grant, what do you got?
Hello, my name's Grant Gabler. It's nice to meet you all. I've already contacted a couple faculty about stuff, and I actually have applied already. I was wondering, I just had a question about, because from my understanding, you only needed to submit your unofficial transcripts so would we only need to submit the official ones then, if we actually get in, I assume? Is that how it works?
Yes, that's how it works. So you just upload all the required documents and then I can look at your application, and if you're academically qualified, I will send it to our faculty looking for BME PhD students at this point in time.
Okay, sounds good. Thank you.
Yep. Yep.
So I'd also like to emphasize that it's important for students to reach out to faculty that they're interested in working it with. And the reason for that is that the students, when they come, will be working directly in that faculty's member's lab from the get-go. That faculty member would, especially if this is a PhD student, if it's a PhD student, that faculty member is going to be, in essence, paying the bills from the get-go. And so it's important that you make and establish that connection, that you're interested in that particular person's lab and what, why you're interested with them. By working in that lab, they're able to, have you work right from the first semester. So instead of taking a full course load for the first year, like you probably would do at other programs, oftentimes you'll do like a half course load, and then spend the other half doing directed research, and thereby able to, again, make progress on your academics while simultaneously getting involved in research right away, as opposed to a year or two later. It's for all these reasons that we're able to, get students through the program in a timely manner. And so there's not, we don't use a rotation system at the current time, so just kind of applying and then coming and then seeing which lab works is not the model that we're necessarily using here. So it's really important you establish that relationship, because without that relationship, it's going to be pretty hard to come, even if you have, really good scores and meet our admission requirements.
Yes, absolutely. So we'll get to Austin momentarily. Feel free to ask questions of any specific faculty member if you wish. So Austin has a question. Go ahead.
It's okay. Thank you so much. I really do appreciate the expository session so far. The question is this: am I expected to submit unofficial transcripts pending the admission decisions?
You can submit, when you apply, you can submit unofficial transcripts. And as soon as you get all the other components in there, it's pretty easy, really. 3 letters of reference, resume, 1-page essay about why you want to come to University of South Florida, why do you want to go into BME. That's pretty much it. And once all those components are uploaded, including unofficial transcript, then we can process your application. We can see if any of the professors are interested in you. You can contact the professors you're interested in. It's only after you're accepted and you're getting ready to matriculate that you would have to submit your official transcripts.
That's right. And the second question is tied to the response you gave to my initial questions. That's in relationship to my questions about my passion for the intersection of computer science and biomedical engineering
right.
Initially. I really want to know, am I supposed to contact any professor in this regard?
The professors that are eligible for you to work with would be on our website. So they would include our primary faculty and our affiliate faculty. In your case, we also have some faculty at Moffitt. So our department name is medical engineering. I know it's a little confusing, but we run all the BME biomedical engineering academic programs. So you would go to the medical engineering website. You would look on our primary and affiliate faculty. Now, in your case, we have some faculty at Moffitt that do exactly what you're talking about. So you could email me, and they're eligible to co-supervise BME graduate students.
It's all right. It's all right. It's all right.
Yep.
Thank you so much.
Yep.
I really do appreciate it.
Right, I don't see anything else in the chat.
Any other questions for Friday afternoon? Okay, well, we thank you all for coming, and please follow up in the ways that we've talked about if you would like to join us in Tampa for your PhD or master's. Have a good weekend.